So in today's session, we will look at the science of reading and how we learn to read. But to begin with, let's look at your screen and figure out if most of us and all of us can read this. I'll give you a moment. Right? So it doesn't matter in what order the letters in a word are. The only important thing is that the first and the last letter be at the right place. So for most of us, we will be able to read just the top section and figure out what it is that is making sense for us. So this is the significance of letter position in word recognition. So here we are recognizing the entire word rather than just each single alphabet. So back in the 1970s, a researcher in the UK figured this out. Of course, research in the area of reading was still happening. So we move on to how this actually works in our visual system. But to give us a little bit of background for a little bit of perspective, the ancient versus modern reading systems still rely on symbol recognition. We read actual alphabets now because we are expert readers. But for a writing system to originate, there were individual symbols. So on the left side of your screen, you see ancient writing systems. I believe most of us or none of us will be able to make any sense of them. But those on the right side, which is describing or showing you the modern systems of reading, these are the alphabets from most popular languages, some of the most popular languages on the planet, and we are able to read most of them. How does that happen? Because learning to read actually is an acquired skill. We, as primates, make sense of the world visually. Have you come across any creatures that read? Have you seen a monkey read, or a dog, or your cat, or a rabbit? Reading doesn't come naturally to most creatures, including primates. In fact, when we are learning to read, our brain cells are making new connections. That's why it takes time to learn to read. You know, we go to school to learn to read. We are taught by our parents, by our peers, also by media, right from early impacts on our nervous system. So we are making new changes. Essentially, the brain is changing, something called neuroplasticity, because as we learn to read, the brain undergoes substantial pruning of nervous or neural connections. We'll look at some of those details in a bit in today's session. There's a lot of work on scientific studies of reading. So specific areas of the brain are involved in reading process. Here I have shown in the picture with colored maps, particularly the areas called primary auditory area or Broca's area, Wernicke's area, and some others that are involved in reading. Now, reading is not a single mental process. It involves subskills such as letter recognition. We just noted that we recognize alphabets from our own languages. So I showed you, in the previous example, alphabets from Cyrillic as well as from Chinese or Devanagari or modern Roman alphabet. So we recognize those individual letters. In this, let us say take an example of school. So S, C, H, O, O, and L makes a school, but we don't read it as a S, C, H, O, O, and L individually as we become expert readers. We read the entire word. And when we read the entire word, we understand or develop knowledge of letter sound rules, how these specific symbols are to be pronounced in certain contexts, something called word comprehension. So when we learn that school is school, but not stool, because CH can refer to a different sound in other languages or in other contexts in the same language. So word comprehension involves not just these subskills, but also many other. What are those subskills and how do we learn about them? So before we go further, let's look at the visual system that enables learning or reading. Most of us are very familiar with the world in terms of visual input. We have two kinds of pathways that provide this information. Anything that we see in the world, there are two primary visual pathways that provide input. One is called a magnocellular pathway here in the diagram shown by blue color here. This is collecting information in the world, which is at the periphery. So our voluntary eye movements or spatial coding of letters, which means how far apart those letters are, visual counting and span, as well as motion stability. this information is carried by this visual pathway. So from your eye to the back of your brain, this visual pathway actually carries this specific type of information. This is also collecting information primarily from periphery, the sides of your eye, rather than at the center. The other pathway shown here in red or orange is parvocellular pathway, which is responsible for fine resolution. When you stretch your arm in front of you and you look at your thumb, and you focus your eyes at your thumb, you're actually paying attention to this area, and then you are unable to detect a lot of things with clarity at the periphery. So in this case, your parvocellular pathway, which has a concentrated input at the center, is active. This is involved in identification of letters and alphabets, and it's also involved in visuomotor coordination. Recall that when you're trying to read, you want to be stationary. You can't generally read in a moving bus or in a moving vehicle. It's really hard. So these magnocellular and parvocellular pathways are critical in reading. Now, we don't want you to get into all the details of these technical aspects of these pathways. There's a lot of work in this. If somebody is interested, they can write to me, and I can share more research on this topic. Just to give you an example, now on your screen, you will see, especially those who are sitting on a computer, that if you see the focus word at the center, you will have difficulty recognizing the words at the periphery, either on the top or on the right and the left, if you don't move your eyes. If you keep your eyes at the central word, you will have difficulty making sense of the word on the peripheral side. You have to move your eyes to either side or to the top or the bottom to make sense of the word, or to recognize and read that word. Now, just take a moment for that, and you can see that this works for everybody. Let us try one more thing. Now I have changed the color of the specific alphabet. Now try and figure out, just keep your eyes at the center on the word, and particularly the colored alphabet in that word, and try and read from the periphery. Especially try and detect which color alphabet is visible when you keep your eyes at the center. It will be incredibly hard to do that if you don't move your eyes. This gives you an example, or this is a demonstration that your eyes have to move from periphery to the fovea, again to the periphery, to be able to read the three words. So here there is a clear example of how magnocellular and parvocellular pathways are working. The central part, information is coming from parvo, and peripheral information coming from magno. For any intelligent reader, when you read this in research papers, you would be surprised how much of work has gone into magnocellular and parvocellular theories of learning and learning disabilities. There is a lot of work on scientific studies, particularly looking at reading and what happens when a child learns to read. I mentioned the subskills. Remember, the alphabet recognition, and then the word recognition, and then the word and the sound relationship, and finally word comprehension. So if a child has a problem in any of those subskills, reading will not proceed normally. Children's reading difficulties come in various different forms, depending on which subskill is compromised or the child has a difficulty with. So it's not just one kind of aspect that can be handled and your child will be able to read, or an individual will be able to read. There are several subskills that can be individually or collectively compromised, or maybe not properly developed. Now, what happens in the brain when you're reading? As I mentioned, from the visual point of view, we all learn visually. The input goes to the back of your brain, a particular area. We call it primary visual cortex. But just remember that it comes from, initially the input is at the back of your head. So letter and word recognition happens in this area, following which the information goes to another area in the brain called visual word form area. This area is quite unique. It makes sense of the sound and the symbol connection. So this is more on the temporal side, both on the left and the right. More for typical readers, more on the left side of the brain. And then we learn there is another area in the brain which is involved in word pronunciation. So you notice that there are different areas involved. And finally, there is access to meaning. So different areas process different information, and there is coordination and activity across the hemispheres as well. As I mentioned, back in the about 20 years ago, researchers were still discussing, or were discussing then, that can the magnocellular pathway learn to read, and what happens to the attentional mechanism. So it's not just vision. I'm showing you neuroscience research articles, titles of those. The advantage in being magnocellular. So magnocellular system is not just involved in visual inputs, but it's also involved in attentional mechanisms. So you can see alphabets. But people who have difficulty in dyslexia, for instance, can see the alphabet, but they can't read it. So it involves not just visual input or sound inputs, but also attentional mechanisms. So to be able to see but not to read, the magnocellular theory of dyslexia has been in the field for about 2 to 3 decades now. As I mentioned, for typical readers, the information goes more on the left side of the brain, here shown in the picture here. The two brain images with typical readers and dyslexic readers. So for dyslexia, many times the information is not properly either collected from the visual system or it is not processed in the typical fashion. The other issues regarding learning disabilities is not just visual input, but also lack of research expertise and poor diagnosis. So many times people are misdiagnosed with dyslexia. Also the case with autism and ADHD. We'll touch upon those a little bit, but not in detail because today's session is more introductory. So a lot of people think that it's just poor reading, which we can deal with. The parent is told the child will grow out of it, which is not true. If your brain mechanisms are not collecting the right kind of information and not processing that information properly, it will be really hard as the child grows up to be able to have fluent reading and language comprehension. There is also an issue of lack of knowledge among medical professionals regarding remedial measures. So sometimes medical doctors or psychologists might know that they have the client or the child or the students have some conditions, but they don't know what kind of remedies exist. Talked about visual inputs, but there is also a critical role of working memory and executive function, which is compromised in a variety of conditions, not just in reading disabilities, but also in autism spectrum, in attention deficit and hyperactivity disorder, in dementia, in dyslexia, and aphasia, various kinds of cognitive deficits. And they have significant associations with real life experience. So people have tremendous stress as a result of these. They have anxiety and depression. Sometimes they develop suicidal tendencies, and then they are referred to a psychiatrist or a psychologist for stress-related solutions, whereas the problem lies elsewhere. The problem is in basic comprehension or reading right from early childhood or in teenage years. One critical aspect of reading involves working memory. So for instance, right now when you're listening to my session, you will have some memory of what were the previous slides and what was the information shared. This information is there in your mind for a short period of time. This is called working memory. So this is a critical component of verbal memory as well as learning and cognition. It is also involved in episodic memory. It's also involved in a variety of other functions like numeracy, which means ability to count, paying attention, spatial memory, ability to navigate or remember words and things. So specific brain areas like prefrontal cortex and anterior cingulate gyrus shown on the top left, those are involved in processing this kind of information we call working memory. We'll come back to working memory again in a few minutes from now, because this is a critical aspect. When a child is trying to read or trying to make sense of things, let us say in a classroom, a teacher is writing something on the board and expects the child or a student to copy it down in the notebook. They can read from the board, but when they want to copy it down in the notebook, it becomes really hard because they have to keep that information from the visual input to the working memory, finally to the motor coordination in which they will be able to put that information in writing. So even writing is compromised as a result of working memory systems not working properly. Let's look at some real life examples. Here we are meeting Alex. He's 10 years old. He has been diagnosed with ADHD and social anxiety. He has low self-esteem and poor academic performance in class. He lives with the limitations of learning disabilities. He's not really dumb, but by social feedback or other people telling him, Alex starts to believe that he's dumb. He's not dumb. He just has learning disabilities or learning difficulties, let us say. At an early age, this thing begins to take shape. Let's look at another example. Let's meet Lucy. She's 16 years old. She's extremely smart, but has poor English skills. She will have difficulty mastering her second language. Maybe English is her second language. And she will have challenges getting employment because English is critical to a global context of employment. So in this case, she is very smart, but has poor language skills. So in some cases, second language skills. Also, let's meet Asha. She's 13 years old. She was diagnosed as a young child with autism. She has severe sensory needs, behavioral as well as communication challenges. Her parents got her diagnosed quite early on, and now they're paying thousands of dollars or rupees, more than her peers, to send her to a private special school because public schools have limited support. So there are lots of examples around us with a lot of young people who are facing difficulties in this domain. Why are we focusing on this so much, or why I would talk about such a topic? Because every day about 700 million people with learning disabilities are struggling to navigate the world. In fact, 75% of all school dropouts have learning disabilities. And many children, actually 2/3 of children diagnosed with ADHD and ADD, which is attention deficit and hyperactivity disorder or attention deficit disorder, actually have learning disabilities. So they may be misdiagnosed, or they could co-occur. We know that 1 in 10 children have learning disabilities. So it's a matter of recognizing these challenges, because many of these people face anxiety and fear about interacting with their peers or in social contexts. They exclude themselves from normal everyday experiences at times. As a result of their learning disabilities, their median salary is generally half of that of their peers. This data is from the US. 75% of these people actually end up in prisons, and they have severe issues regarding unemployment and multi-generational poverty, as well as mental health issues. So learning disabilities don't just have outcomes or repercussions in the context of classroom settings. They have far more social and health-related outcomes. Another condition quite well known these days, or sometimes more discussed in the media, is attention deficit hyperactivity disorder, also called ADHD. It occurs mostly, is diagnosed and occurs mostly in children, but there are adults with ADHD as well. In the US context, there are about 6.4 million people between the ages of 4 to 17 who have been diagnosed with ADHD. Here, I want to point out that it's important to recognize that there are various subtypes of ADHD. So here I'm showing you a data from 2019 research paper showing that actually only 13% of the total ADHD count are combined type, which means they are either both inattentive and hyperactive. The individual inattentive issues or individual hyperactive type of ADHDs are also quite large, 44 and 43% respectively. So ADHD occurs quite across the globe here. This is the data from 2017. That was the latest I found from the ADHD Institute. So right across the globe, there is tremendous amount of research going on in this field, mostly from the diagnostic point of view. This graph, this plot shows you the percentage of people diagnosed with ADHD condition. Remember, some of them could be misdiagnosed. They could overlap with other learning disabilities. And where do we come to from those conditions? Drugs. Many times people expect that if there is a problem, there will be a single pill solution. So for quite a while, ADHD has resulted in circularity of solutions with actually more problems cropping up as a result of unidimensional approach to such conditions. So it co-occurs with learning disabilities or anxiety and depression, increased injuries, peer problems, and generally drugs are not necessarily the primary or the best solution. Sometimes they help. So the traditional standard care of neurodiverse population, here I'm introducing a term neurodiverse, which means a variety of approaches to learning. So different brain systems that have different pace of learning, so neurodiversity in that sense. So these approaches have their plus points as well as certain weak points. So both expensive one-to-one standardized therapies are being used, as well as drug interventions. and behavioral and compliance training. Many of these are inaccessible to many people or a large section of people because of the cost or the time frame, as well as side effects, particularly from the drug-related interventions. Let's look at some cases with regular population, not learning disabilities per se, but real life examples from actual assessments. So some of us, or many of us, might have heard of the PISA scores, or these are actual tests done on 15-year-old pupils across the world. Those who participate, most of the countries participate in these. These people are tested every 3 years. So here's the data from 2018. The last one that was available, because the 2021 will be tested this year. So the OECD average shows that this is data for the learning skills. We see that the Chinese and the Singaporeans and the Macau and the Hong Kong scores are at the top. Just 4 countries, I will show you in another slide, just 4 countries in the European Union actually have a score above average. And many countries are not, kids from many of other countries are not doing so well. This is from the top performance list. In today's session, I will focus a little bit more on the European example. We have many more people from the EU today. So this is the 2018 PISA data. Remember, this is not any dyslexia or learning disabilities data. This is just regular reading. So here you will see that the underachievers are essentially described here by a particular scale where these 4 countries from the left, Estonia, Finland, Ireland, and Croatia, actually just 3, Estonia, Finland, and Ireland are not the underachievers. Rest, all of them are suffering because at the center is the European Union average. So more than 1 in 5 in the European Union, these kids cannot complete even a simple reading task. So this is data sourced from the European Commission website. This data is adjusted for socioeconomic status. So countries like Bulgaria and Romania, as well as Hungary and Slovakia, are not very different in terms of underachievement scores, despite measuring the or equating for the socioeconomic conditions. So the benchmark of 15% here shown with a golden line. So many countries are actually performing poorly in the last session or last assessment. Only Estonia, Ireland, Finland, and Poland are doing better than the EU benchmark, and rest of the countries like Denmark, United Kingdom, Slovenia, Sweden, Portugal, all the way to Bulgaria are not performing even up to the EU benchmark. What does it show? What does it show? It shows that underachievement is increased in reading over the past decade. So reading scores are actually falling. So in 2015, the EU average was 20.1%. Now in 2018, just 3 years later, the average score was 21.7%. So reading scores are falling. What's going on? Is it just a matter of teaching, or why such low scores? Research shows that children who start below stay below. So the data is from 15-year-old children or kids who are tested for these skills. Of course, there is mathematics data and other data as well that we are not discussing today. We are focusing on reading as such. We know that trouble with early word reading skills lead to less time spent reading. So children who have difficulty recognizing symbols or making sense of those words, or understanding the relationship between that word and the particular sound in many irregular languages like English, they will have slow vocabulary growth. They will miss out on many opportunities to practice those comprehension strategies. They wouldn't want to pay attention to a show in a particular language because they don't understand, they don't have a well-developed vocabulary. So as a result, they will continue to fall behind. Back in the 1990s, actually, a researcher pointed out that the best solution to improve such scores and to improve reading is to allocate resources early on. We need to identify early on and find prevention. So there is a lot of research going on since the 90s. In fact, from the 70s onwards, we have known a bit about what is the science of reading and how it works. But there are a lot of gaps between science and application. There's lots of relevant research, but it has little impact on curriculum and classroom practices. not out of any conspiracy, but because teachers or administrators or even curriculum specialists are never trained in these kinds of things. They're never trained in the science of reading. A person has to seek out this information, like going to a special event, like today's webinar. Many people have absence of background knowledge. So people are unprepared to evaluate scientific findings. So you may read about some scientific evidence or new finding on reading in the news media, but you will have difficulty going back to a research paper and figuring out what it really means. What does that research translate into? Can this be fixed? Yes. we are introducing a program called Read On, which is an artificial intelligence-based cognitive reading therapy. This is a new program. This is a patent pending technology. We have applied for patent. This is based on the foundations of neuroplasticity. Neuroplasticity refers to the capacity of the brain to learn and to make new connections. In Read On, we are targeting the auditory, the visual, and the cognitive pathways while enhancing reading and comprehension skills. So Read On is a product from a company called Orange Neurosciences. It's a Canadian company. It's a growth stage digital startup offering next generation therapeutics. It's based on machine learning and AI-based methods. ReadOn.ai is the company's first commercial product, which is being targeted for cognitive therapy for learning disabilities. So all these pictures you see at the bottom are the kids and even adults playing games. This is actually a game-based learning method. So ReadOn.ai uses a variety of neuroscience-based learning to translate into a program. It works on your executive memory, on your working memory. As I pointed out in the beginning, working memory is critical to short-term as well as long-term memory. It's critical to learning. It's critical to episodic memory, which refers to what happened at a particular moment. You remember things better. Read On actually uses attention and reward based information to change your behavior. Essentially, it's making neural connections and leverages the power of engagement. So it's working, as I mentioned, on the principle of brain plasticity, the capacity of the brain to modify itself or rewire itself. It boosts phonemic awareness, which means separating words into individual sounds and gradually introducing blends of those words. I will give you a demo of the Read On in a few minutes from now. So Read On uses multi-targeted approach where auditory and visual pathways are given input so that a person can make those connections better. Game-based process where strengthening of coding and decoding skills is prioritized. And at the same time, peripheral and central visual inputs are also utilized. So eye tracking is a critical aspect. As I mentioned in the beginning, peripheral vision is important for reading. It also improves your executive functioning skills and problem solving. There is actually evidence on using these kinds of methods. So from other researchers, this is a paper I'm mentioning from Gabriele's lab at MIT. So these people have shown that neural deficits in dyslexia can be ameliorated by behavioral remediation. They have evidence using functional MRI work, brain imaging work, showing that if you can train people on certain methods, for instance, your magnocellular pathway can learn, it can actually improve by specific kinds of training. So this is a Frontiers paper on magnocellular training, improving word recognition. There's more work in the field. In fact, many other people, many other companies like Brain Gym and are using Read On to increase word and reading comprehension. Read On particularly focuses on working memory as well as executive function. So again, something that I invite everybody to take a look at. How it works. So in a classroom setting, the principal, for instance, has their own dashboard with the school level performance data. The teachers have their own individual dashboards. They can review student performance through a remote session. They can assign students remote assignments. So it works on a computer. You just need an internet connection and basic auditory output system like a headphone. Students play those games and they complete those sessions either at school or at home. And later on, the scores can be shared with everybody, all those who are part of the program, including teachers and principal, also parents. Here, I will show you, this is the actual screen. So when you sign up for ReadOn, you put a student name here, level, different levels of the program. So from age group of 5 onwards, and different sessions, there are in all 15 sessions. So when you get a login and a password and you start play, it's like a game. So I will just start this and you can take a look at how this works.
Drag the bees from the left side to the right side to make the same pattern. Now drag the bees from the right side to the left side to make the same pattern. Drag the colored hexagons from the left side to the right side to make the same pattern.
Targeting the visual pathways and the eye movements here with different levels of difficulty. There are 9 different games.
Listen for the word. Catch the ball with the matching word and place it into its designated area. Rack. Rack. Back. Back. Find these hidden words and place them on the lines. The park was dark. The flute was cute. Find the right word and place it onto the cloud. Top. Mop. Great! Now find the missing letters to spell the word. He held the top of the mop. L. Bell. L. Bell. Find the right word and place it onto the cloud. Ben. Great! Now find the missing letters to spell the word. Ben. Pick the right word and place it into the square. Pan. Bear. The bear left scratch marks on the tree. Bear.
Working with homophones, similar sounding words.
Peace. Working towards peace is a noble goal. Peace. bear. The bear left scratch marks on the tree. Bear. Peace. Working towards peace is a noble goal. Peace. Find the word in Pig Latin and put it onto the line. Decode the Pig Latin word, then find the correct word and put it onto the line. Decode the Pig Latin words, then find the correct words and put them onto the lines.
So essentially, we do for a study program, do a pre-assessment and also visual processing deficit measurement, and then we prepare step by step for actual study. When we conduct this in a school setting, you're welcome to join us for study as well. So read-on program or the cognitive training runs for 5 weeks, and read-on accelerator runs for 10 weeks, a total of 15 weeks of training. We can also do post-assessment to see changes in the reading as well as word comprehension and visual processing skills. This program has been in use for a while. We have several testimonials from parents as well as therapists. We welcome all of you to get in touch with us, and we can share more details regarding this. This is so far, this was mostly available to the therapists. Now we are making it available directly to parents and students so that they can practice at home. There is very little training required that we provide when you sign up for this. We have a variety of collaborators across the globe on research as well as on training contexts, particularly many research institutions across the globe, right from Singapore to North America and Europe. We have several peer-reviewed conference papers and ongoing studies on this topic. Many school curriculum programs are also involved, particularly in Canada, as well as in India. So I invite all of you to sign up for a free pilot, particularly the schools and therapists can join us for a free pilot. For individuals and parents, they can get in touch with us if they would like to try this or buy it for their kids or for their family members. I also invite you to join a cognitive training support group for those who would like to learn more about or share experiences or learn about people who have already used read-on